Hello, everyone, and welcome. Today, we're jumping right into the fascinating world of physics, specifically the fundamentals of mechanics. This is where we learn how things move, and believe me, it's not always as simple as it looks. To see exactly what I mean, let's kick things off with a little puzzle.
All right, take a look at this diagram. Imagine you start at point A. You walk 5 kilometers over to B, then 2 kilometers down to C, then another 5 kilometers back to D, and finally 2 kilometers back up to where you started, right at point A. The question seems pretty simple. How far did you travel in total? Go on, take a moment to think about it.
So, got your answer? Well, this is where things get really interesting. In the world of physics, this simple little question can actually have two completely different and both totally correct answers. How is that even possible? Well, it all comes down to a really, really important concept. And that key concept? It's the difference between what we call scalar and vector quantities. Understanding this is absolutely fundamental to mechanics, and it's exactly what we need to solve our puzzle. Okay, so let's break this down. On one hand, you have scalar quantities. Think of these as just simple numbers. They only have a magnitude or value, like, mass or time. It just doesn't make sense to say 5 kilograms to the east or 10 seconds upwards, right? Then, on the other hand, we have vector quantities. These guys have both a magnitude and a direction. A perfect example is something called displacement, which we're going to get into right now. So, with our new understanding of scalars and vectors, let's head back to our original problem and find those two different answers by looking at distance versus displacement. First up, let's look at distance. Distance is a scalar quantity. What does that mean? It means it doesn't care about direction at all. It just asks one simple question. What was the total length of the path you covered? It's basically the sum of every single step you took.
So for our journey, the calculation is really straightforward. We just add up all the parts of the trip, 5 kilometers plus 2 plus another 5, and the final 2. That gives us a total distance of 14 kilometers. And there you have it. That's our first correct answer. Simple enough, right?
But now let's talk about displacement. Displacement is a vector quantity, which means direction is everything. It honestly doesn't care how long or winding a path you took. It only focuses on one thing. The shortest straight-line path from your starting point to your ending point.
So, think about it. Where did our journey begin? At point A. And after all that walking, where did it end? Right back at point A. Now, this is the absolutely crucial detail for calculating displacement. The start and end points are identical, which means our total displacement is 0 kilometers. And this just illustrates the difference so brilliantly, doesn't it? Even though you walked 14 kilometers, your actual position in the world didn't change from where you began. So your displacement is 0. And that is our second correct answer.
All right, let's quickly summarize what we've learned. Distance is the total path you traveled. That's a scalar. Displacement is the change in your position from start to finish. That's a vector. Because of this, the distance you travel will always be greater than or equal to your displacement. And as we just saw, your displacement can be 0 even if you traveled a really long way.
Okay, let's build on that, because this core idea of scalar versus vector doesn't just stop at distance and displacement. It actually forms the basis for understanding speed, velocity, and acceleration too.
First up is speed. Just like its partner distance, speed is a scalar quantity. It simply tells you how fast you're covering ground, but it has nothing to do with direction. So in our earlier example, your average speed would have been the full 14 kilometers divided by however long it took you to walk it.
Next is velocity. And you've probably guessed it. If speed is the scalar partner to distance, then velocity is the vector partner to displacement. It measures the rate of change in your position. So think back to our journey. While you had a positive average speed, for the entire trip, your average velocity was actually 0, because your total displacement was 0. How cool is that? And that brings us to acceleration, which is another vector. It measures the rate of change of your velocity. Now, this is key. It means you are accelerating any time you speed up, slow down, or, and this is the part people often forget, even if you just change your direction while moving at a constant speed. Speaking of velocity, here's a fun little fact that puts this whole concept on a cosmic scale. Have you ever wondered just how fast you'd need to go to actually leave the planet?
The answer is 11.2 kilometers per second. That's Earth's escape velocity. It's the minimum speed an object needs to break free from Earth's gravitational pull without any further propulsion. That is incredibly fast.
And to wrap everything up, here's a final thought to connect all of this to your daily life.
The next time you open up Google Maps for directions, ask yourself this. Is the route it's giving you showing you the distance you'll have to travel, or is it showing you the displacement between your location and your destination? Something to think about.
If you enjoyed this video and found it helpful, please give it a like, leave a comment with your feedback, and definitely share it with your friends.
And don't forget to subscribe to the channel so you don't miss out on more helpful videos like this one.
For even more practice questions, come and join us on Telegram. You'll find the link right in the description.
And hey, if you want me to make a video on a specific topic, let me know down in the comments below. I'll do my best to make it happen. Thanks so much for watching.